Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 1, October-November 2019. Let's get started. In the diagram, AC and BD are straight lines. Find the value of P and the value of Q. Angles on a straight line add up to 180 degrees. So when we subtract 48 degrees from 180 degrees, we get the value of P as 132 degrees. Vertically opposite angles are equal, and so this angle here is 48 degrees. Angles in a triangle add up to 180 degrees, and so when we subtract the sum of 48 degrees and 55 degrees from 180 degrees, we get the value of Q as 77 degrees. The angles of a quadrilateral are x degrees, x plus 5 degrees, 2x minus 25 degrees, and x plus 10 degrees. Find the value of x. The sum of all the angles in a quadrilateral must add up to 360 degrees, and so this gives us x plus 5 plus 2x minus 25 plus x plus 10 equals 360. X plus 2x plus x gives us 5x. 5 minus 25 plus 10 gives us negative 10. So from here we can make x the subject, and when we do this we get 74. A regular polygon has 72 sides. Find the size of an interior angle. The sum of interior angles in a regular polygon is equal to 180 times n minus 2. In this case, n, which is the number of sides of the polygon, is 72. All the angles in a regular polygon are equal, and so the sum of interior angles in this case will be 72 times the size of one interior angle, which we are going to call x. So from here, when we make x the subject, we get x equals 175. A, B, C, and D lie on the circle center O with diameter AC. PQ is a tangent to the circle at A. Angle PAD is 60 degrees and angle BAC is 20 degrees. Find the values of U, V, W, X, and Y. The angle between a tangent and a radius is 90 degrees. This means that when we subtract 60 degrees from 90 degrees, we get the value of U as 30 degrees. Let's take a look at triangle ACD. The angle subtended at the circumference of a circle by a diameter is 90 degrees. We also know that angles in a triangle add up to 180 degrees. So when we subtract the sum of 30 and 90 degrees from 180 degrees, we get the value of V as 60 degrees. Angles in the same segment are equal, and so these two angles here must be equal. This gives us W equals 60 degrees. Chord AB subtends an angle W, which is 60 degrees at the circumference of the circle, and subtends another angle X at the center of the circle. This means that angle X is 2 times 60 degrees, which is 120 degrees. Angles in the same segment are equal, so this angle here is 20 degrees. OA and OD are radii, which makes triangle OAD an isosceles triangle. Base angles in an isosceles triangle are equal, which makes this angle equal to U, which we have found as 30 degrees. So 30 plus Y plus 20 must equal 90 degrees. This gives us the value of Y as 40 degrees. A, B, and C lie on the circle center O. Angle AOC is 3x plus 22 degrees and angle ABC is 5x degrees. Find the value of x. On the diagram, we have a quadrilateral with 3 of its vertices on the circumference of the circle and the 4th vertex at the center of the circle. This means that this angle is twice angle ABC, which has been given as 5x degrees. Angles formed around a point add up to 360 degrees. So we have 3x plus 22 plus 2 times 5x equals 360. 2 times 5x is 10x. When we group like terms, 10x plus 3x is 13x and 360 minus 22 is 338. When we make x the subject, we have x equals 338 divided by 13, which is 26. Ali and Mo share a sum of money in the ratio Ali is to Mo equals 9:7. Ali receives $600 more than Mo. Calculate how much each receives. So first, let's set up our ratio. If we represent the amount of money Mo receives with x, then Ali receives 600 plus x. From the ratio, we can set up our equation as x over 600 plus x equals 7 over 9. To get rid of the denominators, we can cross multiply, and this gives us 9 times x equals 7 times 600 plus x. When we expand the brackets, 7 times 600 is 4,200. 7 times x is 7x. When we group like terms, 9x minus 7x is 2x. And when we make x the subject, we have x equals 4,200 divided by 2, which is 2,100. This means that Mo receives $2,100 and Ali receives 2,100 plus $600, which is $2,700. In a sale, Ali buys a television for $195.80. The original price was $220. Calculate the percentage reduction on the original price. The percentage reduction is equal to the reduction, which is $220 minus $195.80 divided by the original price, which is $220 times 100%. When we type this into the calculator, we get 11%. In the sale, Mo buys a jacket for $63. The original price was reduced by 25%. Calculate the original price of the jacket. So from the question, we've been told that the new price or the sale price of the jacket is 25% less than the original price. 1 minus 25 over 100 is 0.75. When we make the original price the subject, we have the new price divided by 0.75. We know that the new price is $63, and so when we type this into the calculator, we get the original price as $84. Dinah invests $600 for 5 years at a rate of 2% per year compound interest. Calculate the value of this investment at the end of the 5 years. In this case, we need to apply the compound interest formula. Small a, which represents the initial amount Dinah invested, is $600. R is 2 and T is 5. So when we type this into the calculator, we get her final investment value as $662.45, correct to 2 decimal places. The value of a gold ring increases exponentially at a rate of 5% per year. The value is now $882. Calculate the value of the ring 2 years ago. We need to apply the compound interest formula in this case as well. We are asked to find the initial value of the ring, which is represented by small a. And so we need to make it the subject of the equation. We've been given the value of big A, which is the value of the ring at the end of 2 years, and that is $882. R is 5 and T is 2. And so when we type this into the calculator, we get the initial value of the ring as $800. Find the number of complete years it takes for the ring's value of $882 to increase to a value greater than $1,100. First, let's set up our compound interest equation. We know small a is $882 and r is 5. If you are familiar with the use of log, you can apply it to find the value of t, or we can use a trial and error method to get the value of t. With that being said, we need to find the value of t that gives us the value of big A to be greater than $1,100. When we take t as 4, we get big A as $1,072.08. This value is less than $1,100. When we take t as 5, we get big A as $1,125.68, which is greater than $1,100. This means that t is equal to 5. Calculate the external curved surface area of a cylinder with radius 8 meters and height 19 meters. The formula for the external curved surface area of a cylinder is 2 pi times r times h. We know that r is 8 meters and the height h is 19 meters. So when we type this into the calculator, we get A equals 955 meters squared, correct to 3 significant figures. This surface is painted at a cost of $0.85 per square meter. Calculate the cost of painting this surface. For every square meter painted, a cost of $0.85 is incurred. And so if we are painting a surface of 955 meters squared, the cost incurred is X, which we are going to find. From this ratio setup, we have X equals $0.85 divided by 1 meter squared times 955 meters squared. This gives us X equals $811.75. A solid metal sphere with radius 6 centimeters is melted down and all of the metal is used to make a solid cone with radius 8 centimeters and height h centimeters. Show that h is equal to 13.5. Since the sphere was melted to make the cone, we can say that the volume of the sphere is equal to the volume of the cone. We know the formula for finding the volume of a sphere and a cone. We want to find the height of the cone, and so we need to make HC the subject of the equation. To clear the denominators, we multiply through the equation by 3. This gives us 4 pi times rs cubed equals pi times rc squared times hc. When we make hc the subject, we get 4rs cubed divided by rc squared. Rs is 6 centimeters and RC is 8 centimeters. When we type this into the calculator, we get HC as 13.5 centimeters. Calculate the slant height of the cone. We know the height and the radius of the cone, and so to find its slant height, we can apply the Pythagoras theorem. This gives us x equals the square root of 13.5 squared plus 8 squared. When we type this into the calculator, we get 15.7 centimeters, correct to 3 significant figures. Calculate the curved surface area of the cone. We know the radius and the slant height of the cone, and so all we need to do is put in these values into the formula A equals pi times r times L. When we do this, we get A equals 395 centimeters squared, correct to 3 significant figures. Two cones are mathematically similar. The total surface area of the smaller cone is 80 centimeters squared. The total surface area of the larger cone is 180 centimeters squared. The volume of the smaller cone is 168 centimeters cubed. Calculate the volume of the larger cone. So first, let's set up our ratio. Since we are dealing with area and volume values in this case, we need to take the square root of the area values and take the cube root of the volume values. From the ratio, we can set up our equation as this. To make x the subject of the equation, we cube both sides of the equation. This gives us x equals square root of 180 divided by square root of 80 times cube root of 168 all cubed. When we type this into the calculator, we get x equals 567. The diagram shows a pyramid with a square base ABCD. DB equals 8 centimeters. P is vertically above the center X of the base and PX is 5 centimeters. Calculate the angle between PB and the base ABCD. On the diagram, we have labeled the angle between PB and the base as alpha. We can find alpha by applying SOHCAHTOA. This gives us tan alpha equals the opposite, which is 5 centimeters, divided by the adjacent, which is 4 centimeters. When we make alpha the subject of the equation, we have tan inverse of 5 over 4. When we type this into the calculator, we get 51.3 degrees, correct to 1 decimal place. The diagram shows a triangular field ABC on horizontal ground. Olaf runs from A to B at a constant speed of 4 meters per second and then from B to C at a constant speed of 3 meters per second. He then runs at a constant speed from C to A. His average speed for the whole journey is 3.6 meters per second. Calculate his speed when he runs from C to A. Olaf's speed when he runs from C to A will be equal to the distance he covered between these 2 points, which we have been given on the diagram as 150 meters, divided by the time he took to cover this distance, which we have not been given directly in the question. So let's find this time duration before coming back to this equation. We've been given Olaf's average speed for his entire journey, and this is equal to the total distance he traveled, which is x1 plus x2 plus x3 divided by the total time duration, which is t1 plus t2 plus t3. T3 is the time duration from C to A, and so we need to make this the subject of the equation. This gives us T3 equals the sum of x1, x2, and x3 divided by the average speed minus T1 plus T2. T1 is x1 over v1 and T2 is x2 over v2. x1 is 120, x2 is 180, and x3 is 150. The average speed for the entire journey is 3.6. V1 is 4 and V2 is 3. So when we type this into the calculator, we get T3 equals 35 seconds. So Olaf's speed from C to A is 150 meters divided by 35 seconds, which is equal to 4.29 meters per second, correct to 3 significant figures. Use the cosine rule to find angle BAC. This is what we have when we apply the cosine rule to triangle ABC. When we make angle BAC the subject, we get cosine inverse of B squared minus the sum of AC squared and AB squared divided by negative 2 times AC times AB. BC is 180, AC is 150, and AB is 120. When we type this into the calculator, we get angle BAC equals 82.8 degrees, correct to 1 decimal place. The bearing of C from A is 210 degrees. Find the bearing of B from A. In the illustration, we have indicated the bearing of C from A with a green arrow and the bearing of B from A with a red arrow. To get the bearing we are required to find, all we need to do is subtract angle BAC, which we found in the previous question as 82.8 degrees from 210 degrees. This gives us 127.2 degrees. Find the bearing of A from B. In this illustration, we have indicated the bearing of A from B with a red arrow. This bearing is equal to 360 degrees minus an angle alpha. We can get the value of alpha by subtracting 127.2 degrees from 180 degrees because these two angles are interior angles. This gives us the bearing of A from B as 307.2 degrees. D is the point on AC that is nearest to B. Calculate the distance from D to A. From the illustration, we see that we can apply SOHCAHTOA to find the distance from D to A. This gives us cosine of 82.8 degrees equals the adjacent, which is DA, divided by the hypotenuse, which is 120 meters. When we make DA the subject, we get 120 cos 82.8 meters. When we type this into the calculator, we get DA as 15.0 meters, correct to 3 significant figures. The cumulative frequency diagram shows information about the times taken by 200 students to solve a problem. Use the cumulative frequency diagram to find an estimate for the median. Half of the total number of students, which is 200, is equal to 100. And so when we map this on the cumulative frequency diagram, we get the median as 34 minutes. Find an estimate for the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. For the upper quartile, we need to map 3/4 of 200, which is 150 on the diagram, and this gives us 43 minutes. For the lower quartile, we need to map 1/4 of 200, which is 50 on the diagram, and this gives us 25 minutes. When we subtract 25 minutes from 43 minutes, we get our final answer as 18 minutes. Find an estimate for the number of students who took more than 40 minutes. When we map 40 minutes on the cumulative frequency diagram, we get n equals 140. And so to find the number of students who took more than 40 minutes, we subtract 140 from the total number of students, which is 200. This gives us 60. Roberto records the value of each of the coins he has at home. The table shows the results. Find the range. The range is the difference between the maximum coin value, which is 50 cents, minus the smallest coin value, which is 1 cent. And so the range is 49 cents. Find the mode. The mode is the coin with the highest frequency. So from the table, the highest frequency is 4, and the coin with this frequency is 20 cents. Find the median. The median is the coin that is in the middle of the total number of coins. From the table, this coin has a value of 10 cents. Work out the total value of Roberto's coins. The total value of Roberto's coins will be the value of each coin times the coin's frequency. This gives us 1 times 3 plus 2 times 1 plus 5 times 3 plus 10 times 2 plus 20 times 4 plus 50 times 2 cents. When we type this into the calculator, we get 220 cents. Work out the mean. The mean is equal to the total value of Roberto's coins, which we have found as 220 cents, divided by the total number of coins, which is 3 plus 1 plus 3 plus 2 plus 4 plus 2. This gives us 14.7, correct to 3 significant figures. The histogram shows information about the masses of 100 boxes. Calculate an estimate of the mean. The mean is equal to sigma f of x, which is the total mass of all the boxes, divided by sigma f, which is the total number of boxes. To find sigma f of x, we first need to find an average mass for each of the mass ranges and the frequency for each range. For the range m greater than 0 and less than and equal to 10, the average mass value is 0 plus 10 divided by 2, which is 5. For the next range, the average mass value is 10 plus 15 divided by 2, which is 12.5. And for the final range, the average mass value is 15 plus 30 divided by 2, which is 22.5. To get the frequency for each range, that will be the frequency density times the interval width. So for the range m greater than 0 and less than and equal to 10, the frequency will be the frequency density, which is 3, times the interval width, which is 10 minus 0, giving us 30. For the next range, we have 8 times 15 minus 10, which is 40. And for the final range, we have 2 times 30 minus 15, which is 30. So sigma f of x is 30 times 5 plus 40 times 12.5 plus 30 times 22.5 divided by 100. This gives us the mean as 13.25. Oranges cost 21 cents each. Alex buys X oranges and Bobby buys X plus 2 oranges. The total cost of these oranges is $4.20. Find the value of X. The total cost of the oranges Alex buys is the unit cost of the orange, which is 21 cents or $0.21 times the total number of oranges he buys, which is X. The total cost of the oranges Bobby buys is the unit cost of the orange, which is $0.21 times the total number of oranges he buys, which is X plus 2. We are told that the total cost of the oranges the two boys buy is $4.20. So from here, we need to make X the subject of the equation to find the value of X. When we expand the brackets, 0.21 times X is 0.21X and 0.21 times 2 is 0.42. When we group like terms, we get 0.42X equals 3.78. And when we make X the subject, we get 3.78 divided by 0.42, which is 9. The cost of one ruler is R cents. The cost of one protractor is P cents. The total cost of 5 rulers and one protractor is 245 cents. The total cost of 2 rulers and 3 protractors is 215 cents. Write down two equations in terms of R and P and solve these equations to find the cost of one protractor. The two equations we are going to write in terms of R and P will be based on these key pointers. From the first statement, we write 5 times R plus 1 times P equals 245. And from the second statement, we write 2 times R plus 3 times P equals 215. We can solve these two equations simultaneously using the elimination method. Let's start by eliminating the variable P. And to do this, we'll multiply equation 1 by 3. 3 times 5R is 15R. 3 times 1P is 3P. And 3 times 245 is 735. Let's label this new equation equation 3. Now we can subtract equation 2 from equation 3. This gives us 15R minus 2R plus 3P minus 3P, which is 0, equals 735 minus 215. 15 minus 2R is 13R and 735 minus 215 is 520. So when we make R the subject, we get 520 divided by 13, which is 40. Now that we have found the cost of one ruler as 40 cents, we can easily find the cost of one protractor by placing this value into any of the equations. If we pick equation 1, we have 5 times 40 plus P equals 245. When we make P the subject, we get P equals 45. And so we have the cost of one protractor as 45 cents. Carol walks 12 kilometers at x kilometers per hour and then a further 6 kilometers at x minus 1 kilometers per hour. The total time taken is 5 hours. Write an equation in terms of x and show that it simplifies to 5x squared minus 23x plus 12 equals 0. Here is a simple illustration of the scenario given in the question. Between the first 2 points, we've been given the distance traveled as 12 kilometers and the speed as x kilometers per hour. She walks further from the second point to a third point. We've also been given the distance covered between these 2 points as 6 kilometers and the speed as x minus 1 kilometers per hour. We've also been told that the total time taken for Carol's entire journey, which is T1 plus T2, is 5 hours. Using the speed formula, we can write T1 as the distance traveled during the first interval divided by the speed. We can also write T2 as x2 over v2. So now we have 5 equals 12 over x plus 6 over x minus 1. The LCM is x times x minus 1, and when we multiply through the equation by the LCM, we have 5x times x minus 1 equals 12 times x minus 1 plus 6x. When we expand the brackets, 5x times x is 5x squared. 5x times negative 1 is negative 5x. 12 times x is 12x and 12 times negative 1 is negative 12. When we move all the terms to one side of the equation and group like terms, we have 5x squared minus 23x plus 12 equals 0. Factorize 5x squared minus 23x plus 12. Negative 23x can be rewritten as negative 20x minus 3x. When we factor out 5x from the first 2 terms, we are left with x minus 4. And when we factor out negative 3 from the final 2 terms, we are left with x minus 4. This can be rewritten as 5x minus 3 times x minus 4. Solve the equation 5x squared minus 23x plus 12 equals 0. Since we factorized 5x squared minus 23x plus 12 in the previous question, we can rewrite this equation as 5x minus 3 times x minus 4 equals 0. When we equate 5x minus 3 to 0, we have x equals 3 over 5. And when we equate x minus 4 to 0, we have x equals 4. Write down Carol's walking speed during the final 6 kilometers. We were given Carol's speed during the final 6 kilometers as x minus 1 kilometers per hour. And now we have 2 possible values for x. When we pick x equals 3 over 5, we get a negative value for v, which is not possible in this case, and so we go with x equals 4. This gives us Carol's walking speed as 3 kilometers per hour. The diagram shows 5 cards. Donald chooses a card at random. Write down the probability that the number of dots on this card is an even number. This probability is equal to the number of cards with an even number of dots, which is 4, divided by the total number of cards, which is 5. So we have 4 over 5. Write down the probability that the number of dots on this card is a prime number. This probability is equal to the number of cards with a prime number of dots, which is 4, divided by the total number of dots, which is 5. So we have 4 over 5. Donald chooses 2 of the 5 cards at random without replacements. He works out the total number of dots on these two cards. Find the probability that the total number of dots is 5. There is only one possibility in this case, which means he picks a card with 2 dots and a card with 3 dots. However, depending on the order in which these cards are picked, we have two different possibilities or scenarios. So in the first scenario, he picks a card with 2 dots first and picks a card with 3 dots second. And in the second scenario, he picks a card with 3 dots first, then a card with 2 dots second. The probability that he picks a card with 2 dots first is 3/5. Without replacement, the probability that he picks a card with 3 dots second is 1/4. The probability that he picks a card with 3 dots first is 1/5. Without replacement, the probability that he picks a card with 2 dots second is 3/4. And when we type this into the calculator, we get 3/10. Find the probability that the total number of dots is an odd number. There are two possibilities or scenarios in this case. In the first scenario, he picks a card with 2 dots and a card with 3 dots. There are two different orders in which these two cards can be picked, and so we multiply this by 2. In the second scenario, he picks a card with 3 dots and a card with 4 dots. In this scenario as well, there are two different orders in which these two cards can be picked, and so we multiply this by 2. The probability of picking a card with 2 dots first is 3/5, and the probability of picking a card with 3 dots second is 1/4. The probability of picking a card with 3 dots first is 1/5, and the probability of picking a card with 4 dots second is 1/4. When we type this into the calculator, we have 2/5. A car hire company has X small cars and Y large cars. Write down 3 inequalities in terms of X and or Y to show this information. The company has at least 6 cars in total. This means that the number of small cars and large cars the company has, which is X plus Y, is greater than or equal to 6. The number of large cars, which is Y, is less than or equal to the number of small cars, which is X. The largest number of small cars is 8. This means that the number of small cars, which is X, does not exceed the number 8, and so it is less than or equal to 8. A small car can carry 4 people and a large car can carry 6 people. One day, the largest number of people to be carried is 60. Show that 2x plus 3y is less than and equal to 30. So the number of people carried by the small car, which is 4 times x, plus the number of people carried by the large car, which is 6 times y, does not exceed the number 60, and so is less than and equal to 60. When we divide through this equation by the common factor 2, we get 2x plus 3y is less than and equal to 30. By shading the unwanted regions on the grid, show and label the region R that satisfies all 4 inequalities. Before we can shade the unwanted regions, we need to draw the boundaries or the lines for each of the inequalities. So for all 4 inequalities, we draw the lines x plus y equals 6, y equals x, x equals 8, and 2x plus 3y equals 30. For the first inequality, x plus y is greater than and equal to 6, the region above the line is wanted, and so we shade the region below the line. For y is less than and equal to x, the region below the line is wanted, and so we shade the region above the line. For x is less than and equal to 8, the region below the line is wanted, and so we shade the region above the line. or to the right of the line. For 2x plus 3y is less than and equal to 30, the region below the line is wanted, and so we shade the region above the line. After shading the unwanted regions, we label the unshaded region on the grid R. Find the number of small cars and the number of large cars needed to carry exactly 60 people. From the graph, 6 small cars and 6 large cars are required. We can confirm this by checking 4 times 6 plus 6 times 6, which gives us 60. When the company uses 7 cars, find the largest number of people that can be carried. First, let's pick up the set of coordinates in the wanted region that add up to 7. When we slot these coordinates into the equation 4x plus 6y, these are the values we get. The largest number from this list is 34, and so that will be our final answer. Complete the table for the 5th term and the nth term of each sequence. For the first row, the numbers have a common difference of -4 between them. And so to get the 5th term, we have -3 minus 4 giving us -7. To find the nth term of a sequence with a common difference, we apply this formula. A1 is the first term of the sequence, which is 9, and D, which is the common difference, is -4. When we simplify this further, we have 13 minus 4n. For the second row, we have a quadratic sequence, and we can choose to use the formula process for quadratic sequences to find the nth term. Or we can shortcut this process by observing that when we add 1 to n equals 1 and square it, we get 4. When we add 1 to n equals 2 and square it, we get 9. And so for the 5th term, when we add 1 to 5 and square it, we get 36. The nth term will be n plus 1 squared. For the third row, we have a cubic sequence, and this is pretty straightforward. 1 cubed is 1, 2 cubed is 8, and so 5 cubed is 125. And we have the nth term as n cubed. For the fourth row, we have a geometric sequence because there is a common ratio of 2 between the terms. And so for the 5th term, we have 64 times 2 giving us 128. To find the nth term of a sequence with a common ratio, we apply this formula. A1 is the first term of the sequence, which is 8, and the common ratio is 2. We can leave the nth term in this form or simplify it to a base of 2, which leaves us with 2 raised to the power n plus 2. This sequence is a Fibonacci sequence. After the first 2 terms, the rule to find the next term is add the 2 previous terms. For example, 5 plus 8 is equal to 13. Use this rule to complete each of the following Fibonacci sequences. For the first row, we have the first 2 terms. For the next term, we add 2 and 4, giving us 6. For the next term, 4 plus 6 gives us 10. And for the final term, 6 plus 10 gives us 16. For the second row, we only have the first of the first 2 terms and the term at the end. What we can do is represent the 3 blank spaces with x, y, and z. So this means that 1 plus x is y, x plus y is z, and y plus z is 11. We can solve these equations using the calculator, and we get x equals 3, y equals 4, and z equals 7. For the third row, we only have the second of the first 2 terms and the term at the end. Let's represent the blank spaces with a, b, and c. So this means that a plus -1 is b. This is the same as a minus 1 equals b. Then we have -1 plus b equals c. b plus c is 1. We can solve these equations using the calculator, and we get a equals 2, B equals 1 and C equals 0. One term of this sequence is P over Q. Find in terms of P and Q the next term in this sequence. To be able to find this, let's take a look at two consecutive terms in the given sequence. We notice that the denominator of the previous term becomes the numerator of the next term, and the sum of the numerator and the denominator of the previous term becomes the denominator of the next term. This means that if we have P over Q as a term in the sequence, the next term will be Q over P plus Q. Find the sixth term of this sequence. From the list, we have the fifth term as 11 over 18, and so the sixth term will be 18 over the sum of 11 and 18, which is 29. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.